identify types of functions from a table. So how can we tell by looking at a table what kind of function we have? Well, first let's identify the types of functions we care about. So we are going to focus primarily on linear and exponential functions, reminding ourselves that linear functions are a constant rate of change, meaning we are adding or subtracting the same number over and over and over to get this function, and therefore because it's constant, that would be linear. An exponential function is a proportional rate of change found by either multiplying or dividing. I just want to remind you that if we are dividing by a number, let's say we divide by 2, we can change that to multiplication. Remember the rules of dividing fractions from whenever. We change division to multiplication, and we multiply by the reciprocal. So dividing by 2 is the same as multiplying by 1/2. That's why multiplying and dividing basically are the same thing. But when you have a consistent multiplication, so we multiply by 3, we multiply by 3, we multiply by 3, that's an exponential function. All right, let's look at these. So table 1. You'll notice that we are dealing with consecutive numbers, okay? That is important because if we have consecutive values, then we can compare our y values. So what happens as we go from 2 to 4? Well, we are either adding 2 or multiplying by 2, right? Then we look at the next one. From 4 to 6, I'm adding 2. I am not multiplying by 2. So this is no longer an option because it is not consistent. It is not constant. Either with linear or exponential, you have to have a constant change. It's either adding or subtracting, or it's a proportional constant change with multiplying and dividing. My last one from 6 to 8, I'm also adding 2. So this here is linear with a constant change of +2. Now, when we look to the table 2, from 0, 1, 2, 3, great. So these are also consecutive numbers. That's good. So now I look at my comparison. From 1 to 4, I'm either adding 3 or multiplying by 4, from 1 to 4. Then I go from 4 to 16. I'm either adding 12 or multiplying by 4. Well, 3 and 12 are not the same, and therefore this is no longer even an option because it's not the same. Then I go 16 to 64. Yep, that is also multiplied by 4. So this would be an exponential model with the proportional change of being multiplied by 4. All right, let's determine whether the following tables, there will be 3, represent a linear function, an exponential function, or neither. Okay, always verify. Am I dealing with consecutive numbers? I go from 1, 2, 3, 4. Yes, these are consecutive. Check that first. Once you see you have a consecutive, then compare 15 to 11, subtract 4. 11 to 7, subtract 4. 7 to 3, subtract 4. Great. They are all the same, and therefore this represents linear with a change of -4. You have to check all of them because you're looking for the consistent piece. If they are not all the same, then it doesn't work. Table B, verify. 1, 2, 3, 4, check. These are consecutive. So now I can compare 2 to 8. Okay, I'm either adding 6 or multiplying by 4. 8 to 8. I'm either adding 0 or multiplying by 1. 8 to 2, I'm either subtracting 6 or dividing by 4. And now you're going, what is happening? All of these aren't the same. These aren't the same. So this is neither. This is not linear. This is not exponential. This is something else. And the last one, verify. 1, 2, 3, 4. These are consecutive numbers, so I can look at the y values to compare. Okay, 2 to 6. I'm either adding 4 or multiplying by 3. Notice how I'm writing all of this down. I highly recommend that you write things down. Math is so much easier when you can see it. When you start just putting everything in your head, it just gets so jumbled in there, at least mine does. 6 to 18, well, that's adding 12 or it's multiplying by 3. Okay, notice plus 4 plus 12, these are no longer an option. So now 18 to 54, yep, If I take 18 times 3, I do get 54. So this is exponential. It's an exponential function with a proportional rate of change of multiplying by 3. And that's playing with tables.